Hi everyone, welcome to iTrust. My name is Aditya Mathur. I'm the Center Director, and it's time for us for a brief tour of the iTrust test beds that will be used during the CISS 2021. So we'll start with SWAT. SWAT stands for Secure Water Treatment Plant. This is one of the first test beds that we built in 2015. This is a 6-stage test bed for water treatment. I'll take you through all the 6 stages. So right here we have stage 1, which is the raw water stage, and the PLC which you see here inside this cabinet is responsible for getting the water from outside, which is from SUTD, into this raw water tank. There's a valve behind this raw water tank. When opened, the water comes into this tank. So that is one of the goals of PLC 1, to make sure that this tank is always full, or at least water is available in this tank for filtration. So water flows from stage 1 to stage 3 via stage 2. What you see here are 3 tanks. This is tank 201. It has NaCl. Then this is a tank which has HCl. And this is a tank that is NaOCl. And you can see the orange colored pumps for dosing these chemicals into water. The PLC here, which is the second stage PLC, is responsible for controlling these pumps, and it does so with the help of the 3 chemical parameters, which are pH, conductivity, and ORP. Once these parameters are set, the water is of course flowing to stage 3, where it is ready for filtration. We are now in stage 3. The PLC in stage 3 is responsible for managing ultrafiltration. So what it does is, the water which is to be filtered is in this tank, and it uses the pumps here to move the water through the ultrafiltration unit here, the white cylinder, up through this, and the water comes out, the pure water comes out and goes to the RO feed tank in stage 4. So this is the ultrafiltration unit, the white cylinder, and the water goes from bottom and comes out at the top, from where it goes to the tank which is the RO feed tank. There's a pump here which is used to move the water from the UF feed tank outside to the RO feed tank. There is also a differential pressure indicator which indicates the pressure drop across the ultrafiltration unit. If the pressure drop is beyond the threshold, then a backwash process is started to clean the ultrafiltration unit, where the small particles in water are stuck, and that's what causes the pressure drop to increase. We are now in stage 4. The primary purpose of stage 4 controller, the PLC 4, is to make sure that the water that goes to the reverse osmosis stage does not have free chlorine. So it does so by moving the water through this UV dechlorination unit. This unit has 6 UV lamps, and when the water flows through this, free chlorine is removed. We also have NaHSO3 tank here. In case this is not working, then that's a backup. All right, we are now in stage 5. PLC in this cabinet, PLC 5, is responsible for controlling this most complex stage of the entire system. What happens here is that there's a variable speed pumps which is used to move the water at a high pressure through the reverse osmosis units. We have a 2-stage RO system, and the water flows through this and comes out of it as a permeate, which is the pure water, and a reject, which is the not so pure water. These 2 streams go into different tanks which are on the other side of the RO units. We are now in stage 6, and as I said earlier, water from RO comes into this tank, which is the RO permeate tank, and this tank, which is the UF backwash tank. The PLC 6 is responsible for controlling the outflow of water from these 2 tanks. It recycles the water from this tank by moving it into the first tank, the raw water tank, and it is also interacting with PLC 3 by moving the water from the backwash tank through the ultrafiltration unit from top to down, and then the water that comes out after cleaning the UF tank is drained. So the entire system, entire SWAT is controlled through the SCADA, which you can see here, and this is connected to all the PLCs via a network. The communication is through different protocols between the SCADA and the PLCs, and amongst the PLCs, and also among the PLCs and the actual devices through the RIOs, the remote IO units. So that completes our tour of the SWAT test bed. I will now take you to the water distribution test bed. All right, we are now inside WADI, the water distribution test bed. The water into this distribution test bed comes from 2 possible sources. The SWAT that we just now saw, the water can come from there, and also it can come from outside. And it is possible for us to control the inflow of water from either source or from both the sources. So I will now take you through the 3 stages that constitute the water distribution test bed. So stage 1 is controlled by the PLC for primary grid. This is the entire primary grid. You can see the primary grid tank here. These are 2,500 liter tanks, a total of 5,000 liters. Before the water is moved from the primary grid to the secondary grid for consumers, it is dosed with 2 chemicals to control the ORP and conductivity of water. This entire process is controlled by the primary grid PLC. Okay, we are now in stage 2 of WADI. This stage 2 is controlled by the consumer tank PLC, PLC2. What you see here are the 2 tanks which actually distributed to the consumers. It is possible for us to use one of the RTUs, the remote terminal units, which are Schneider Electric units, that would actually simulate water poisoning. So we have another sampling station here, which is another remote terminal unit, Schneider Electric, which is used to sample the water that is coming from the dosing place, which that I just mentioned, to check whether the water is suitable for drinking before it is actually sent into the secondary grid. We are now in the last part of stage 2. Here you can see 6 consumer tanks here, and the water from the secondary grid just falls into these tanks, consumer tanks, through gravity. However, if the pressure, because of high demand or whatever, is low, then there is a separate booster pump which will actually move the water from the secondary grid to the consumer tanks at a high pressure. And the consumer demand itself is set through the SCADA that I'll show you later, where a 24-hour demand pattern can be set in advance so that the PLC2, which you saw earlier, will be able to control the flow of water to the consumer to meet the demand. So we are in stage 3 of WADI. On my left is the return tank, and on my right are the pumps and various valves which are used to move the water from the consumer tanks to the return grid back to the primary grid. What you see here is the SCADA workstation that is responsible for controlling the entire water distribution process by communicating with the different PLCs through different protocols. Again, the PLCs communicate with the devices via the RIOs, again using Modbus and other kinds of communication protocols. I'm entering this CyberX room where the blue teams will be based and they'll be defending the systems, the 4 systems, from here. As you can see, we have already created an area where 12 or so members of blue teams can be sitting. Blue teams need to be a bit large because 4 systems are to be defended, 2 for water treatment and 2 for water distribution. So let's see what's here. So these are systems where the blue team members will be able to look at the data that is coming from all the 4 plants. If they are able to access through the internet, they could access HMI also. Then in that case, they'll be able to see the HMIs right here. Also, we have, if you can see right there, toward the end in the center, we have 4 screens above the iMac, and those screens will be showing the HMIs of all the 4 plants, the 2 plants for water treatment and 2 for water distribution. And then on the other side, of course, we have just a few posters that talk about the architecture of the entire system. So this is our CyberX room, which is used for cyber exercises that we do every year. We do about 3 cyber exercises every year, and this is where we conduct those exercises. All right, so we are now at the end of the tour. To summarize, I have shown you SWOT, WADI, and our CyberX room. I wish you all the best. Thank you very much. Best wishes.